Hello, everyone. In previous lessons, we learned about timers, counters, and their applications, and mastered the usage of timing and counting. The Intel MCS 51 has two external interrupts, INT0 and INT1. Today, we will explore the usage of external interrupts. In this lesson, we will cover the following three aspects. 1. Examples of external interrupts. 2. Triggering methods for external interrupts. 3. Summary of the interrupt system. Let's start with examples of external interrupts. External interrupts refer to interrupts where the interrupt sources come from outside the microcontroller. We will use the example of an LED flashing to illustrate this. By pressing a switch to control the LED state, this operation is not an external interrupt but rather a counter that counts the switch presses. Interrupts caused by timer overflows are considered internal interrupts. First, let's look at the circuit for the LED. In its normal state, it implements LED flashing control. We add two push-button switches to this circuit, connected to the INT0 and INT1 pins. The goal is that when no switches are pressed, the LED flashes. When K1 is pressed, external interrupt INT1 is activated, causing the LEDs to light up sequentially from right to left, D1 to D8. When K0 is pressed, external interrupt INT0 is activated, causing the LEDs to light up sequentially from left to right, D8 to D1. Next, let's review the control program for this circuit. The overall structure of the program includes four functions: main, delay, and the two ISRs for INT0 and INT1. In the ISR for INT0, the LEDs light up sequentially from left to right, D8 to D1, and the interrupt priority is set to 0. The ISR for INT1 makes the LEDs light up sequentially from right to left, D1 to D8, with its interrupt priority set to 1. The TCON is set to 0x00. Let's compare this with the TCON calculator. We can observe that the actual configuration involves setting the trigger mode for external interrupts. Specifically, INT0 and INT1 are set to level triggered mode with INT0 equals 0 and INT1 equals 0. Additionally, the interrupt flags are cleared with IE0 equals 0 and IE1 equals 0, which disables the external interrupts. The interrupt enable register, IE, is set to 0x85. Referring to the bit positions in the IE register, EA equals 1 enables global interrupts, ES equals 0 disables the serial port interrupt, ET1 equals 0 disables T1 interrupts, EX1 equals 1 enables external interrupt INT0, ET0 equals 0 disables T0 interrupts, and EX0 equals 0 disables external interrupt INT0. When no interrupts occur, the LED continues to flash. During simulation, observe that without pressing any switch, the LED flashes. Pressing K0 causes the LED to light up from left to right, D8 to D1. Releasing K0 restores the flashing. Pressing K1 causes the LED to light up from right to left, D1 to D8. Pressing K0 again lights up the LED from left to right because INT0 has a higher priority than INT1. Conversely, if both K0 and K1 are released and K0 is pressed again, the LED lights up from left to right. Pressing K1 again will not change the LED lighting sequence. This example demonstrates the effect of interrupt priority and the concept of interrupt nesting. Having understood the example of external interrupts, let's move on to the triggering methods for external interrupts. External interrupts can be triggered either by level or by edge. This can be configured by setting the IT0 and IT1 bits in the TCON register. In the example above, we configured the external interrupts to be level triggered. This means that as long as the INT0 or INT1 pin remains at a low level, the interrupt request is valid. Thus, pressing K0 or K1 continuously executes the ISR until K0 or K1 is released. Now, let's configure INT0 and INT1 for edge-triggered mode by setting IT0 equals 1 and IT1 equals 1, making TCON equal to 0x05. We will modify the control program accordingly, recompile, and run the simulation. Observing the results, we see that pressing K0 or K1 causes the ISR to execute only once before returning to the main program. This is because pressing K0 or K1, regardless of the duration, only generates a single edge transition and thus only one interrupt request. In this lesson, we covered examples of external interrupts and their triggering methods. Combined with the previous course content, we have completed the explanation of interrupt concepts and their applications. Interrupts are a crucial concept in computing, widely used in control systems. Please consolidate your learning and complete the relevant exercises to master the related knowledge. In the next lesson, I will explain serial port interrupts. That concludes this lesson. See you next time.